Welcome back to a third video on rectilinear motion. So now we're going to try and work out a WACE exam question. So this is a question from the year 2017, question 20 in the Calculus Room section. So a model train travels on a straight track such that its acceleration after t seconds is given by a equal pt take 13, where t lies between 0 and 10 and p is a constant. Determine the initial acceleration of the model train. Now we've seen this before. To find the initial acceleration, that is, the time is 0. So we just have to substitute t by 0 in the given equation. So p times 0 is 0. 0 takes 13 is negative 13 centimeter per second square. So that's quite an easy question. That's why it's worth only 1 mark. Now the next bit. The model train has an initial velocity of 5. That means when t is 0, v equal 5. After 2 seconds, it has a displacement of negative 50. That means when t equal 2, x equal negative 50. A further 4 seconds later, its displacement is 178. Now when it says a further 4 seconds later, that means when t is 6. Because you add 4 to the 2 seconds. So when t is 6, you'll get x equal 178. Now to do this question, we'll start first by finding v. So v will be integral of acceleration, which gives us pt squared on 2 take 13t plus c. Now we sub the initial conditions to find the value of c. So when t is 0, v is 5. And then that means c also equal 5. Hence we get an expression for the velocity, which is pt squared over 2 take 13t plus 5. Now to find x, we have to anti-differentiate v, which gives us pt squared on 2 take 13t plus 5, the integral of that, and that work out to be pt cube on 6 minus 13t squared over 2 plus 5t plus k. Now note we didn't use c again just to avoid confusion, so instead we use any other letter, say some random letter k, where k is a constant. Now after 2 seconds it has a displacement of negative 50, so we replace t by 2, x by negative 50, and then since it's Calculus Room, you can just simplify this on your calculator, which gives you equation number 1, which is negative 50 equal 3/4 p take 16 plus k. Now we repeat the process using t equals 6, x equal 178, and then we'll come up with a second equation, which I have labeled as equation 2. Now, as you're aware, your class pad has a solve facility, so you just have to plug in the 2 equations and the 2 unknowns, and then you'll get the value p, which is 12. K is not required, but we can just write it down. K is negative 50. So next part of the question, when is the model train at rest? Now at rest means v equals 0. So now that you know the value p, we can plug the value p back in v. That will give you 12 over 2, which is 6. So we get 60 squared take 30t plus 5. And again, it's Calculus Room, so you just solve this on your calculator, and that will give you t equal half, or 513 seconds. And last question, how far has the model train traveled when its acceleration is 47? So the acceleration is 47, that means pt take 13 is 47. Again, we know the value p is 12, that means 12t take 13 is 47. Solve, you'll get t equal 5. So basically you have to find the distance traveled within the first 5 seconds. So we're going to use the formula that we showed in the second online video. Distance travel will be integral from 0 to 5, magnitude of v dt, and just plug that on your class pad and the answer will come up as 115.7. So hope you liked the video. We'll see you next time. Bye.